AB Cactus BC, Unit 7, Day 4, office hours. These were out of the Kennedy book, Orange book. I should check your odds in the back of the book. These are the evens. Pause the video if you need to check them. Okay, assuming you guys have checked your answers, your evens, and your odds in the back, let's do these. So, first problem today, find the area of the shaded region analytically. So, not using geometry, use calculus. So, number one, I'll just draw a picture. The picture is very helpful if you're trying to find the area between curves to know which one's on top, which one's on bottom. So, it's kind of looks like a cosine curve. It's cosine squared. And you're trying to find this area right here. And this is a horizontal line, y equals 1. So the period of this is actually be pi, not 2 pi, because all the negatives are getting squared. So it looks like a cosine curve, but it's a little different. So if we want to find the area of this, we would integrate y top minus y bottom. So the top is 1, the bottom is the cosine squared curve, dx, 0 to pi. And we can't integrate cosine squared, so we're going to use that identity, double angle identity for cosine that we learned a while back. It is 1/2 plus 1/2 cosine double angle. But you have to distribute the subtraction. So the antiderivative will be x over 2, or yeah, that'd be 1/2. So it's going to be x over 2. It's going to be minus 1/2. We're going to get a sine of 2 theta should be the 2x is the antiderivative of cosine 2x. It's going to give an extra 2 in front, so we need an extra 1/2 because of the chain rule. Because we do want a 1/2 there when we're done. And it's going to be minus 0 to pi. And so we're going to get pi over 2 minus 1/4. Sine of 2 pi is 0. And plug 0 in, we're going to get 0 minus 1/4 of 0. Sine of 0 is 0. So those terms all drop out. And we get pi over 2. Okay. Next problem, number 3. So we have, they call this x equals y squared, which is the same thing as y equals the square root of x. It's top half of a sideways parabola. And then they give you another function they call x equals y cubed, which is y equals the cube root of x, which is gonna, be shorter than y equals the square root of x once you get past 1, which is where they intersect. 1, 1, 0, 0. So we're trying to find this area here. You could do it with horizontal slices. They kind of gave it to you very nicely set up for horizontal slices, or you could do vertical slices. I guess I could do it both ways. Y top minus y bottom, vertical slices. The area is going to be the integral from 0 to 1. Y top is the cube root of x, x to 1/3. Y bottom is the square root of x, x to 1/2, dx. So it's going to be x to the add 1. So it's going to be 4/3, 3/4 minus x to the 3/2. Divided by the new exponent, multiplied by the reciprocal, 0 to 1. So you're going to get 3/4 minus 2/3 minus 0 minus 0. And so least common denominator would be 12. So that's going to be 9/12. That's going to be 8/12. So that'd be 1/12. Or we could do horizontal slices, x right minus x left. And so this is a different option. We would integrate in the y direction 0 to 1. X right in terms of y is y squared. X left is y cubed. The integral is a little nicer. I mean, the antiderivatives are easier. No rational exponents. Y cubed over 3 minus y to the fourth over 4. 0 to 1. So you get 1/3 minus 1/4 minus 0 minus 0. And least common denominator would be 12. 4/12 minus 3/12 is 1/12. Same answer. So you got options. Okay, so that's number 3. Number 4 is kind of crazy looking. So it looks like that. And then there's another one that looks like that. And we're trying to find this area here. So it's kind of crazy. The functions, they're given to you in a way that is friendly for horizontal slices. X equals 2y squared minus 2y. And this one is x equals 12y squared minus 12y cubed. And I don't think we want to do vertical slicing because vertical slicing will require you to solve these y's in terms of x, which that looks really hard and maybe not possible. So I think we should do horizontal slicing and set up very nicely for it. We just saw in the last problem that it was actually nicer when you did it that way. And I just don't think we have a shot at doing vertical. So a equals, we're going to go 0 to 1. X right in terms of y is 12y squared minus 12y cubed minus x left. And you got to be careful here. You got to subtract the whole function. So I'd put parentheses around it just to be extra careful, and then you could distribute. We could simplify this, combine like terms. 12y squared minus 2y squared is 10y squared minus 12y cubed. Minus 12y cubed and plus 2y. So it's a little nicer. So antiderivative is going to be 10y cubed over 3 minus 12y to the fourth over 4 plus 2y squared over 2. That's going to be a 3. The 2's reduce. So when you plug 1 in, you're going to get 10/3 minus 3 plus 1. Plug 0 in, you're going to get 0 minus 0 plus 0. So least common denominator would be 3. So it's going to be 10/3 minus 9/3 is 1/3. Horizontal, vertical slicing would have been crazy just to even try and make happen. And I'm sure the work would have been a lot messier than this also. Now let's see, I made a mistake. It looks like, oh, I forgot this 1 right here. So it's 4/3 actually. I just ignored it. So 1/3 plus 1 is 1 1/3, 4/3. Okay, 6. 6 is an interesting graph. Looks like that. Looks like that. So what are the functions? This is y equals x squared. That's parabola. This is y equals negative 2x to the fourth. So it's a quartic that pretty much looks like an upside down parabola. And it seems like they give you some of these values. I think this is at 1. This is -1 to 1. This is -2. Okay, so, all right. And vertical slicing will work very nice. Horizontal slicing, I think, would be kind of painful on this one because you'd have two different sets of integrals because left it would be tough. So I think we'll just stick with vertical slicing. So y top is x squared minus y bottom is -2x to the fourth dx from left to right, -1 to 1. So the antiderivative is going to be x cubed over 3 plus 2x to the fifth over 5 from -1 to 1. Some symmetry here, so I think, I don't know, seems like we might get the same values from both sides. Plug 1 in, you get 1/3 plus 2/5. Minus, you plug in -1, you get -1/3 minus 2/5. Right, so it's the same value. We're going to get 2/3 plus 4/5. Least common denominator would be 15. So it's 10 plus 12 is 22/15, or 1 7/15. All right. Okay. Number 9 says find the area of the shaded region analytically. So same kind of problems. Drawing is very helpful on these, especially with multiple curves. So we have y equals x, and then we have a horizontal line, y equals 1, and then we have what looks like sort of like a parabola. It is x to the x squared over 4. So we're trying to find this region here. Now, horizontal slicing would work great on this one. But if we did vertical slicing, we're gonna have to break it up and do y top minus y bottom over here, and then you have to do a different y top minus y bottom over here. So it's definitely gonna be more work. I mean, we could do it both ways. So y top would be x minus x squared over 4 for the first chunk, dx, 0 to 1. And then and then 1 to 2 of y top would be 1 minus y bottom dx squared over 4 dx. So this is what you're going to have to do if you do vertical slicing. So it's going to be x squared over 2 minus x cubed over 12, 0 to 1, plus x minus x cubed over 12, 1 to 2. So it's going to be 1/2 minus 1/12 minus 0 minus 0. Plus this is going to be 2 minus 8/12 minus 1 minus 1/12. Okay, so 6/12, so it's going to be 5/12. That's 2/3. So 6/3 minus 2/3 is 6/3 minus 2/3 is 4/3. Least common denominator would be 12. So 12 minus 1, that'd be 11/12. Okay, least common denominator is going to be 12. So it's going to be 16, 21. That's going to be 10/12 or 5/6. Okay, now that's vertical slicing. Let's try it with horizontal slicing. So horizontal slicing would instead be one set of one integral, x right minus x left. We would need to get this x in terms of y, which would be plus or minus 2 square root of y, right? That's going to be positive because it's right half. So it's 2 square root of y minus x left is just y, dy, 0 to 1. So that's your whole integral instead of all of that stuff. So it's going to be x to 3/2 divided by the new exponent minus x squared over 2, 0 to 1. So it's going to be 4/3 minus 1/2 minus 0 minus 0. Least common denominator would be 6. So you're going to get 8 minus 3 is 5/6. I think that was a little easier. Right? I don't know. Little. I think it's worth it. 5/6. Same way. Either way. Horizontal or vertical. Okay. Number 10. Another piecewise graph. So we have a parabola, y equals x squared, and then we have a line, x plus y equals 2, which is the same thing as y equals negative x plus 2. And I think these guys cross at 1, 1. 1, 1. So this is the area. So, I think horizontal slicing would work out really nice here because it would just give you one set. Otherwise, you have to divide it up and do y top minus y bottom and y top minus y bottom. You have to set up two different integrals. So the area is going to be, if you do vertical slices, it's going to be 0 to 1 of x squared, and then 1 to 2 of negative x plus 2. So you're going to get x cubed over 3, 0 to 1, plus negative x squared over 2 plus 2x, 1 to 2. You're going to get 1/3 minus 0 plus, this is going to be negative 4 over 2, negative 2 plus 4 minus negative 1/2 plus 2. Okay, so that's going to be positive 2. It's going to be 1 and 1/2. It's going to be negative. That's going to be 1. So it's going to be 1/3 plus 1/2. Least common denominator would be 6. So 2 over 6 plus 3 over 6 is 5 over 6. So 5 over 6 is your answer. Doing it with vertical slices. Now horizontal slices, it would just be one set of slices, x right minus x left. And x right would be 2 minus y, and x left would be the square root of y, and you would integrate 0 to 1. So just one integral. The antiderivative is going to be 2y minus y squared over 2 minus y to the 3/2 divided by the new exponent, 0 to 1. So you get 2 minus 1/2 minus 2/3 minus 0 minus 0 minus 0. So least common denominator would be 6. So it's going to be 6 minus 3 minus 2 would be 1. Okay, no. 12 minus 3 minus 4 would be 5 over 6. Same answer. It's up to you, but it might be good to be good at both of them. Okay, 15. 15 is y equals x squared minus 2 and y equals 2. Find the area of the regions closed by lines and curves. So I think we should graph these. That's just a flat line. This is parabola shifted down 2 units. So up 1 over 1, over 2, up 4. So they have nice intersection points that I figured out just from doing my quick sketch. So I'm trying to find the area in between them. So vertical slicing, I think, is the way to go here. Y top minus y bottom. So area equals negative 2 to 2. Y top is 2. Y bottom is x squared minus 2. Make sure you distribute that subtraction. So it's going to be 4 minus x squared. So it's going to be 4x minus x to the third over 3, negative 2 to 2. It's going to be 8 minus 8 thirds minus negative 8 plus 8 thirds. So it's going to be 16 plus 16 thirds. These come in the denominator, 48, 64 thirds, or 31 and 1/3. Or 30, did I do that right? Oh, hold on. It should be minus 16 thirds. So that's going to be 48 minus 16 is 32 thirds. 32 thirds or 10 and 2/3. I messed up that. I acted like those were positive 8/3, but they weren't. Okay, let's see. 18. 18 says y equals x to the fourth minus 4x squared plus 4, and y equals x squared. So we have a quartic and a parabola. So maybe we should try and graph them. It might be helpful to find the zeros. So the x-intercepts of this graph are going to be double roots. They're going to be plus or minus the square root of 2. So x equals plus or minus the square root of 2 are going to be the roots of the quartic, which is about, square root of 2 is like 1.7 or something. This is just a regular old parabola. You know, do kind of rough sketch. One, two, 4. So that's your parabola. And then the quartic, like I said, the quartic has x-intercepts that are like right around here. Square root of 2, negative square root of 2, and positive square root of 2. And at 0, it's up here at 4. So it kind of goes, these are double roots. So then it comes back up like this. Now what might be interesting, if we plug 1 into this, we get negative 3 plus 4, we get 1. So 1, 1. Oh, that's kind of nice. That's like right there at those same nice points of the parabola. And then if we plug in 2, we get 16 minus 16 is 4. Oh, wow. So, I mean, that might have taken a bit of algebra to figure out, but the intersections of these are really nice points. This is at 2, 4. This is at negative 2, 4. This is at negative 1, 1. This is at 1, 1. We're trying to find the area between them, which changes which functions on top or bottom at different points. We're going to have to break this up. And, well, let's see. It says region closed by the curve. So, yeah, we're going to I think we're going to need to break this up. We could use symmetry. I don't know. That sounds nice. And just do half of it and then double it. Okay. I mean, otherwise, and the work's going to be very similar, but it might be nicer plugging 0 in for one of the calculations. So the area is going to be double the integral from 0 to 1. Now the one on top is the quartic, x to the fourth minus 4x squared plus 4 minus the y bottom, which was the parabola there, x squared. Okay, plus 1 to 2. The parabola is actually the top one, x squared minus the quartic, x to the fourth minus 4x squared plus 4. Make sure you distribute that division. Okay, so that's the setup. Now we just got to like kind of get through all of this. So antiderivative for this one is going to be x to the 5th over 5. This is going to be negative 5x squared, so x cubed over 3 plus 4x, 0 to 1, plus, if we distribute this, we have positive 5x squared, so 5x cubed over 3 minus x to the 5th over 5 minus 4x. And it's interesting because we got the exact same terms as the last one, but they're all opposite signs, which makes sense because it's the same two curves above and below each other. The antiderivatives are going to be the same, but we did one on top and the other we did the other on top. So it makes sense. So then we're going to plug 1 in here. It's going to be 1/5 minus 5/3 plus 4 minus 0 minus 0 plus 0. And then plus, we're going to plug 2 in, and that's going to be 5 times 8 is 40/3 minus 32/5 minus 8. And then I'm going to plug 1 in. It's going to be 5/3 minus 1/5 minus 4. Ugh. So now we got to just try and simplify all this stuff. Okay, well, can we just combine like terms that we already have? So we have negative 5/3, another negative 5, that's negative 10/3, but then we have positive 4, so it's 30/3, which is nicely 10, okay? We have a 1/5 and another 1/5, that's 2/5, but negative 32/5, so that's negative 30/5, which turns out to be 6. And then we got 4, and then we got another plus 4, but then we got a minus 8, so that turns out to be 0. So this is going to be 2 times 4 is 8. Wow. It kind of worked out nicely at the end. So I don't know, that's the way I would do it. It worked out pretty nice. There, you could do the whole thing. You'd have to break it up into 3 separate intervals, right? But that worked out pretty nice. I mean, it's not the only. Well, my solutions online, I probably have it different. Probably made it a little more. I think the ones I did online look a little harder. Okay, 22 is x equals y squared, and x equals y plus 2. Now, for graphing purposes, I feel like I kind of want to write this like that, but whatever. Okay, so we graph this. So this is a simple line that starts at -2 and has a slope of 1. Up 1, 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 up 1. And the other one's a sideways parabola. Actually, technically, like the top and the bottom. And so it has the same shape of a parabola. Ooh, that's nice. That's like a nice intersection right there. And so I think it makes sense to just do the top half. I don't know. And so that would be this area right here. And this intersection is really nice. It's 4, 2. This is 0, 0. This is 0, -2. So if we do vertical slicing, y top minus y bottom, we would say, all right, integral of the sideways parabola minus what's on the bottom. And we would go 0 to 4. So we would get x to the 3 halves, divided by the new exponent, minus x squared over 2, plus 2x. And then we would plug 4 in. Square root of 4 is 2, cubed is 8, so it'd be 16 thirds minus 16 over 2 is 8, plus 8. Plug 0 in, you get 0 minus 0 plus 0. These guys cancel each other out, and get 16 thirds, or 5 and 1/3. You know, I don't know. I mean, you could try horizontal slicing. It kind of looks more complicated. You would actually have to do 2 different sets of integrals because x right minus x left changes. So I don't know. I feel fine with that. I think I'm going to just stick with the vertical slicing. 26 is 4x squared plus y equals 4, and x to the fourth minus y equals 1. It's the same thing as y equals 4 minus 4x squared, upside down parabola. This is the same thing as y equals x to the fourth minus 1, quartic. We just graphed one of these. This quartic, though, is going to look just like a parabola because it doesn't have any middle terms. So let's see. If we graph this upside down parabola, that's been stretched by a factor of 4. So let's see. Let's see if we do this. 1, 2, 3, 4. We definitely need this up here for the upside down parabola. It's also been shifted up 4 units, right? Plug 0 in, you get 4. If you plug 1 in, you get 0, which makes sense. Usually you go over 1 down 1, but everything's getting multiplied by a factor of 4. If you plug 2 in, it's going to be really negative. So that's your parabola. And in the quartic, if you plug 0 in, you get -1. It's been shifted down 1. If you plug 1 in, you get 0. Oh, that's a nice intersection. Plug 2 in, you get something really big. So it's kind of like this. And we're trying to find the area in between them. They both intersect nicely at 1, 0 and -1, 0. So that's nice. We do vertical slices. Y top minus y bottom. We could use symmetry, just find half and then double it, which worked out pretty nice for us before. Or not use symmetry. It's up to you. I don't know. So I guess here I'll try it without symmetry. So symmetry you could do 0 to 1, which would make things a little nicer. Or you do -1 to 1. And now y top is the upside down parabola, 4 minus 4x squared. Y bottom is the quartic. And then you got to distribute the subtraction. I think it'd be worth it to clean it up first. So it's going to be -x to the fourth minus 4x squared plus 5. Combine like terms, rewrote it in like standard form. Okay, so it's going to be -x to the fifth over 5 minus 4x cubed over 3 plus 5x. And we're going to go -1 to 1. So that's going to be -1/5 minus 4/3 plus 5. Minus, if you plug in -1, you get +1/5, +4/3 minus 5. You can see that symmetry happening. And we distribute this. So we get -1/5, -1/5, we have -2/5. We get -4/3, -4/3, we have -8/3. +5 plus 5 is 10. So least common denominator would be 15. 3 times, 3 times, 5 times, 5 times. So we have -6 minus 40 plus 150 over 15. So -46, 104 over 15. Or, whatever, 10, 6 and 14/15. Is that right? 90, yeah. Or you could have done symmetry. Okay, got a couple more. left to do. So 28 is y equals 2 sine x, and y equals sine 2x, 0 to pi. So I guess let's graph these. So some sine curves. Period is usually 2 pi. Amplitude is usually 1, but this one is twice as high as normal. So 0, 2, 0, -2, 0. And we're just doing 0 to pi. The other one is a sine curve, but the period has been divided by 2, so its period is 2 pi. So we actually get the pattern in half the time. So it's like this. And it doesn't have double the amplitude either. So this is what that graph looks like. So we're trying to find the area in between them, which is going to be this area. Now, we can do this straightforward, or a clever thing you can do is you can see this fills in that hole right there, and you can just integrate this one single curve, and that would give you the right answer. But y top minus y bottom. Y top is the 2 sine x curve. Y bottom is the sine 2x curve. And then it would be 0 to pi. I don't think we'd pull off horizontal slices on this because it involves the inverse sine, which we don't know how to integrate. So the antiderivative is going to be -2 cosine x, and then this is going to be plus 1/2 cosine 2x. Antiderivative sign is negative cosine. This one has a little chain rule issue. You need an extra 1/2 in front. 0 to pi. So it would be -2 cosine of pi is -1. Cosine 2 pi is 1. Plug 0 in. Cosine 0 is 1. Cosine of 2 of 0 is 1. So just because a lot of times we plug in 0, we get zeros, it's not always true. So we have +2 plus 1/2 plus 2 minus 1/2. And so the answer is 4. Now, the clever way of doing it is you say, oh, let's just do 0 to pi of 2 sine x, because this little dip fills in that, and really now it's just the area under that single curve. Let's see if we get the same thing. So -2 cosine x, 0 to pi. Cosine of pi is -1 minus -2. Cosine 0 is 1. And we get 4. And a little simpler. Okay. All right. And so for the last one, it is 30. And 30 is y equals cosine of pi x over 2. Y equals 1 minus x squared. So the period of this curve is usually 2 pi, but we're going to divide by the factor inside, and that's going to give you a period of 4. Just nicely 4 for that cosine curve. So it's a cosine curve and an upside down parabola. That's been shifted up 1. So the cosine curve cosine curve starts up here. The period is 4, so this is 2. So it goes like this, and then it goes like this, and then it goes like this, and it goes like this, and it goes like this, and it goes like that. Okay, the upside down parabola starts up here at 1, and if you plug 0 in, you get 1. Oh, so it they cross each other. It's all right here. You plug in one, you plug in 2, and you get -3. So you have this parabola here, and then you have the sine curve, and the intersections in between them. So you got to know which one's on top of the other. So this is kind of tricky, but it is the parabola. Probably the best way to confirm it would be on a graphing calculator. Now here's the thing: you'll know you did it wrong. You'll know if you did it wrong or not if you get a negative answer. If you get a negative answer, then you assume the wrong one was on top. So the area is integral y top 1 minus x squared minus y bottom cosine of pi x over 2. Like I said, if you mess this up, then you would figure it out. And it goes from -1 to 1, which I discovered while I was just trying to draw the sketch of it, which was nice instead of having to try and do the work. I don't think you're going to solve that by hand, setting those equal to each other. I don't think that's going to happen. So the antiderivative is x minus x cubed over 3 minus, it's going to be sine of pi x over 2, but there's going to be extra pi over 2, so you need a 2 over pi in front. -1 to 1, so you plug 1 in, you get 1 minus 1/3 minus 2 over pi. Sine of pi over 2 is 1, minus -1 plus 1/3 minus 2 over pi. Sine of negative pi over 2 is -1. So there's symmetry here, which you could tell at the beginning, so we could have tried to take advantage of it. So you have 1 plus 1 is 2. You have -1/3 minus 1/3 is -2/3. You have -2 over pi minus 2 over pi minus 4 over pi. These come denominator is 3. So we have 6/3 minus 2/3. So we have 4/3 minus 4 over pi. Wow, that was fun. All right. Okay. Okay. Well, that is it.